Hi everyone and welcome to another YouTube video. In today's video we are going to be solving two questions to actually make us understand the concept of conditional probability. In our last video we actually explained the basis of conditional probability and also give the formula that we can actually use to work on the concept of conditional probability. I'll be linking that video in the top right corner and in the description so you can just go check that out. So without further ado, let's jump into the video and start solving questions properly. So our first question says that Susan took two tests. The probability of her passing both tests is 0.6. The probability of her passing the first test is 0.8. What is the probability of her passing the second test given that she has passed the first test? So we actually have two events right here, and that is the event of her passing the first test and the second event is the event of her passing the second test. So we can say let F represent the event of her passing the first test and S represents the event of her passing the second test. So that means probability of her passing the first test is denoted as P into bracket of F, and the probability of her passing the second test is given as P into bracket S. So let us try to extract the details given to us in the question. It says that the probability of her passing both tests is actually equals to 0.6. So that means probability of her passing the first test and the second test is actually equals to 0.6. So we have P into bracket F intersection S, and that gives us 0.6, and the probability of her passing the first test is actually equals to 0.8. that is probability of F is actually equals to 0.8. We were not given the probability of her passing the second test, so that means probability of S is actually unknown, but the question says we should get the probability of her passing the second test given that she has actually passed the first test. So this is kind of a conditional probability question because event of her passing the first test has actually occurred and we are only interested in the event of her passing the second test given that she has actually passed the first test. So if you want to write this in the probability notation, we are going to be having P into bracket S, we have the slash and F, and we close the bracket. So this represents probability of her passing the second test given that she has actually passed the first test. If you can recall from our previous video, we actually said that probability of A slash B is equal to probability of A intersection B divided by the probability of B. So in this case of ours, probability of S slash F is going to be equal to probability of S intersection F divided by the probability of F. So probability of S intersection F according to our question is actually equals to 0.6 and the probability of F is actually equals to 0.8. So definitely probability of her passing the second test given that she has actually passed the first test is written as probability into bracket S slash F is equals to 0.6 divided by 0.8, and when we use our calculator to do the math, we have our answer to be equals to 0.75. So the probability that she's going to pass the second test given that she has already passed the first test is actually 0.75, aka 75%. So the second question says that below is a two-way table for the data set of how men and women watched action and comedy movie in a theater. So we have the table given to us below. So the question now says if a woman is actually chosen at random, what is the probability that she loves action movies? So the first step is for us to complete the table by adding the total details to each of the column and row. So we are going to be totalizing everything right here. We have 35 plus 10, that gives us 45. We have 40 plus 55, that gives us 95. We have 35 plus 40, that gives us 75, and we have 10 plus 55, that gives us 65. So this simply implies that we have a total of 45 men, a total of 95 women, we have a total of 75 people who loves action movie, and we have a total of 65 people who actually loves comedy movie, and we have a grand total of everyone to be equals to 140. So to answer our question, once again the question says if a woman is chosen at random, what is the probability that she loves action movie? From this question we can see that we actually have two events right here. The first event being the probability that a single person chosen is going to be a woman, and the next event is the probability that a single person chosen is going to be liking action movie. So the question says if a woman is chosen at random, so that means the event of choosing a woman has actually occurred, what is the probability that the woman is going to love action movie? So the conditional probability notation or statement for this question is going to be P into bracket A slash W. That is probability that this woman is going to like an action movie, or we can say probability that the person is going to like an action movie given that she's actually a woman. So the formula is going to be written as P into bracket A slash W is equals to probability of A intersection W divided by probability of W, and we can see that probability of A intersection W is equals to number of people that actually likes action movie, and they are also women, divided by the total number of people. And the probability of her being a woman, or the probability of the person being a woman, is actually equal to the number of women we have divided by the total number of people in the theater. So probability of A intersection W, aka probability of her being a woman and liking action movie, is actually equal to the number of women that loves action movie, which is equals to 40, divided by the total number of people right there, which is equals to 140. And the probability of her being a woman is the number of women we have, which is equals to 95, divided by the total number of people, which is equals to 140. So when we try to slot this into our calculator, we have the probability into bracket A slash W is equals to 40 divided by 140, which is probability that a woman likes action movie, divided by 95 divided by 140, which is probability that a woman is chosen. And when we do the math, we have a 40 divided by 140 times 140 divided by 95, which gives us 8/9. And when we convert this to decimal, we have our answer is to be equals to 0.421. That is approximately 42.1%. So there's a 42.1% chance that a woman chosen at random is actually going to like action movie. If you learned something new from this video and you actually enjoyed this video, I would really appreciate if you can give this video a thumbs up and also subscribe to this YouTube channel. Thanks for making it to the end of this video, and we see you in the next one. Bye for now.